Welcome to Maths for You channel, a past question on coordinate geometry from Sri Lankan A-level past paper. Let A the coordinates of -2, -3, and B the coordinates of 4 and 5. Find the equations of the line L1 and L2 through the point A such that the acute angle made by each of the lines L1 and L2 with the line AB is pi by 4, 45 degrees. The point P and Q are taken on line 1 and line 2 respectively, such that APBQ is a square. Find the equation of PQ and the coordinates of P and Q. Let's deal with that part first. So A, B are the 2 points. The coordinates are given. Find the and 2 lines. So AB line and the coordinates -2, -3, 4, 5. Put a little sketch. And L1 and L2, which are making 45 degrees of pi by 4 with AB. So either side of that. And again, APBQ, the P on L1, Q on L2, APBQ is a square. So the P and Q is such a way that the quadrangle APBQ is a square. Right. So we know those 2 points A and B. And again, APBQ is a square. Therefore, if we draw PQ, we need to find the equation. So PQ and AB are the cuts at T. Cuts at T, and because of APBQ Q are a square, then of course that is AP and PQ are 90 degrees each other, perpendicular each other, and then again it's the TB equal TA equal TP equal TQ. Well, we will come to that later. So all we want to know that's the AB is a line perpendicular to PQ. That to start with, we can find the equation PQ. All right. Before that, the T is the midpoint. Of course, the midpoint, the AB and PQ cuts, and the midpoint T. The T equal, we can find it because AB coordinates are given. From that, the coordinates of T is 4, the x-coordinate of B plus x-coordinate of A is 4 plus -2 divided by 2. So 4 minus 2 divided by 2 is 2 over 2 is 1. And 5 minus -3, 5 plus -3. So 5 minus 3 is 2, 2 divided by 2 is 1. So the coordinates of T, the line PQ and AB intersect as 1, 1. The gradient of AB, we know that because we know the 2 points, so the y-coordinates 5 minus y-coordinate of A is -3, so -3 divided by 4 minus -2. Minus plus, so 5 plus 3, 8, 4 minus plus, 4 plus 2, 6, 8 over 6, 4 over 3. So the gradient of AB is 4 over 3. But we have already said, and we know that because of square, that APBQ are perpendiculars. Therefore, the gradient of PQ is just minus 3 over 4. Because of that, the M1, M2 equal -1 formula. So the gradient of PQ we have found -3 or 4. But then again, we know a point on PQ as well because of T is on PQ. Therefore, we said we know this point gradient and the point on that line. Therefore, easy to find the equation of the line. So y minus 1 over y minus y minus 1 over x minus 1 equal -3 over 4. So y minus 1 over x minus 1 is a gradient. That is equal minus 3 over 4. If you cross multiply and cross multiply that, so 4y minus 4 equal minus 3x minus plus 3. That is 4y plus 3x, and bring that 3 this side, minus 7. That is PQ, equation of PQ, which is the first part, equation of PQ, and the coordinates of PQ. Now the coordinates of PQ. We know the gradient of L1 is, say, just call it L1, ML1, the gradient of L2, ML2. Because of that L1 9 to 45 degrees and L2 45 degrees to AB, the value, so if you look at it, L1 and L2 are perpendicular to each other because of 45, 90 degrees. So the angle between L1 and L2 is 5 by 4 plus pi by 4, which is pi by 2, 90 degrees. So it's perpendicular. PQ square, L1, L2, or in other words, L1, L2 perpendicular because of that square, the set square. So there are various ways to prove that the L1 and L2 are perpendicular each other. So just here took that because of APBQ square, therefore L1 and L2 is the side of the square, so L1 perpendicular to L2, ML1, ML2 equal minus 1. So right, keep it that way. We haven't found the Q yet. We need to go further to find Q. Yes, PQ and P. Yeah, okay. Let's do a bit more work. Right, I'll sketch the diagram again. How I did it. I just draw an x line, the x-axis. Then L, of course, cuts the x-axis, and Y cuts the, L2 cuts the x-axis, L1 cuts the x-axis, AB cuts the x-axis. So just take the angle between L2 and x-axis, say alpha, and L1 and x-axis, theta. So that is tan alpha is the gradient of L2, tan theta is gradient of L1. Let's keep it that way. Then pi by 4, do a little geometry, and the angle here, the angle with x-axis, the AB makes the angle with x-axis, alpha plus pi, or theta minus pi over 4. So just keep it that way, and we will do a bit more work. So AB, the just we look at the gradient way. Just even though it's AB gradient, we know that, but we just wanted to the angle given x-axis angle, that is tan of x-axis, tan of the angle making x-axis is the gradient. So MAB, so the gradient of AB, tan alpha pi by 4. So one angle alpha pi by 4 or theta. I'll do that later on. So it's this is the property of trigonometry, tan A, tan B property. So tan A plus B. So tan alpha plus tan pi by 4 divided by 1 minus tan alpha tan pi by 4. That is a standard trigonometric property for tan two angles addition. So tan alpha, tan 45, if tan pi by 4 is 1 minus again tan alpha. If we cross multiply, here we go, tan alpha is the gradient of L2. So the ML2 plus 1 and minus ML2. From that, we can find sort of cross multiplication. 4 minus 4 ML2 equal 3 ML2 plus 3. And if you bring that ML2 over the other side, so keep that number at one side. So 7 ML2 equal 4 minus 3 is 1. Therefore, ML2 is 1 over 7. So the line 2, the gradient of line 2, 1 over 7. And again, the line 2 is actually going through A. passes A. So we know the gradient, we know a point on that line, therefore equation is simple to find. So it's y plus that y minus 3 over x minus 2. So the y plus minus plus, so y plus 3 over x plus 2 equal 1 over 7. Cross multiplication, it gives us the L2 equation, 7y minus x plus 19 equal 0. So just do some little work. I just jumped these steps. So therefore, that L2 equation found. Again, we know the MAB, we could use the other one, right? The tan theta minus pi by 4. So that can be done as well. So again, a tan property, two angles subtract one another. So tan theta minus tan pi by 4 divided by 1 plus tan theta, tan pi by 4. Again, gradient of AB is 4 over 3, which we have used it before, and we know that. And ML1 this time, ML1 minus, because of the angle theta, is the line L1 makes with x-axis. So ML1 minus 1, 1 plus ML1, cross multiplication, 4 plus 4 ML1, ML1 equal 3 ML1 minus 3. So from that, ML1 is minus 7. But of course, we don't need to go this far. We can easily find as well, because of L1 and L2 perpendicular to each other. L2 is the gradient of L2 is 1 over 7. Therefore, the other one must be minus 7 because of that perpendicular each other. Anyway, we proved it this way as well. So I just another way of doing it right. Okay, so right, equation L1, simply, because we found the gradient. So L1 equation, y, that because of that L actually going through A as well, L1 going through A as well. So y minus 3, so y plus 3, x minus 2, x plus 2 equal minus 7. Cross multiplication, y plus 3 equal minus 7x minus 14. Then bring it to one side, y plus 7x plus 17 equal L2 is this one, and PQ. So this we haven't found that coordinates of P and Q, but the equation of that where is it? Okay, yeah. The points PQ are taken L1 and L2 respectively, because square PQ and PQ coordinates. Right, of course, L1 and L2 they have. How did they ask us to find the L1 L2 angle? No, they haven't actually found the equation L1 and L2, but we do need it. So we just found those equations. So L1, L2, and PQ. Right, okay. So PQ and PL1 is meet at P, because of his P is on L1. If you could do those two equations, L1 and PQ equations, is 4y plus 3x minus 7. This is PQ. Then L1 is y plus 7x, but I just multiply by, so if you could say it's 1, 2, 3. So this is 3. Then this one, 1 multiplied by this 1 multiplied by 4. That is this. So 4y, 4 times 7 is 28, and 4 times 17 is 68. From that, subtract y, eliminate from this one is the one, isn't it? Yeah. So 1 minus 3 gives you 25x. 4y cancelled out, 25x. And plus 7, 68 plus 7 is 75. So x equal minus 3. Y equal, and you just substitute that. Y minus the 4, y minus 7x, y minus 3. So this is equation 1. One equation. If you could substitute that, y minus 3 times 7 minus 3 times 7 is 21 plus 17 as this equation 1. From that, y equal 4. So the coordinates of p minus 3, 4. That is one of the question asked. Again, p, q, and l to meet at q. So just two equations. We know 4y, 3x is 3, number 3, number 2. What I did, actually, I wanted to eliminate x is easier, so I just multiply 3. That's one, just 3. Which one? Second one, yes. And there's x, yeah. Multiply 2 by 3. So this is 2 by 3. That gives you 7 times 3 is 21, minus x times 3 is minus 3x, plus 57. Then add them together. It gives you x eliminate x cancel out. So 21 plus 4 is 25y. And if you add that, 57 minus 7 is 50, and y equal minus 2. Then substitute a value 4 in the equation 3. 4 times minus 2 plus 3x minus 7. The 4 times minus 2 is minus 8 plus 3x minus 7 equals 0. 3x equals 15 minus 8 minus 7, 15. Take to the other side, 15. X equal 5. So y equal minus 2, x equal 5. That is the q, coordinates of q. Now we have found, we already found the PQ equation and the coordinates of PQ. Right. Now read this second part. Also find the equation of the circle S through points A, P, B, Q. Right, let's find that one. So we find the circle which go through this the vertex of this square. So that is straightforward. Right, the center of the circle that passes A, P, B, Q must be must be T. T is 1, 1. And the radius, it can be anything, so XB or XA or XP or XQ, whatever. We know all this, so easier to be an XB. So the center is 1, 1. The radius is the distance XB. A distance found between the 2 points, so the coordinates, we know that. So B coordinates 4 minus 1 squared plus 5 minus 1 squared. 4 minus 1 is 3. 3 times 3 is 9. 5 minus 1 is 4. 4 times 4 is 16. 9 plus 16 is 25. Square root of 25 is 5. Plus or minus 5 is 5. So the circle equation is x minus 1 center, x minus 1 squared plus y minus 1 squared equal 5 squared. So radius squared. That's done. That circle equation found. And further, find the equation of chord of contacts, a chord of contacts of the tangent drawn from the point R to the circle. Of course, the R should be outside anyway. As lambda greater than 1, right now I just missed the part. Circle through the S point. Okay. So equation circle found. In the next line, let lambda greater than 1 show that point R, 4 lambda, 5 lambda lie outside the circle. So, right. So we have put another little sketch. Okay. So it's a circle. The R is outside, 4 lambda, 5 lambda, and the tangent to the circle, the RU and RV. Let's deal with that later. The R is outside, but we need to prove R is outside for lambda greater than 1. Okay, R is just taken as outside, but we need to prove it. So how we prove it? RT is the distance from center to that point. And if the RT is greater than the radius of the circle, then job done. So RT is 2 points. So the distance between the 2 points, RT equals square root of 4 lambda minus 1 squared plus 5 lambda minus 1 squared. And if you remove the expand it, just 4 lambda minus 1 squared, that is 16 lambda squared minus 8 lambda plus 1. And 5 lambda minus 1 is 25 lambda squared minus 10 lambda plus 1. The whole thing to the power of half. When you simplify it, 16 and 25 is 41 lambda squared. 8 and 10 is 18 lambda. 25, 1 and 1, 2 to the power of 2. That is right. So R to be outside, RT should be greater than 5 because 5 is the radius. So we need to prove it. Well, let's take it and prove it the other way. Yeah, well, RT squared is, so if RT greater than 5, they both are positive, so RT squared greater than 25. RT squared, we just got it here, without that to the power of half, is 41 squared minus 18 lambda, 41 lambda squared minus 18 lambda plus 2 greater than 25. We don't know it's greater than, but we wanted to prove it. So 41 lambda squared minus 18 lambda, and bring that 25 this side, 23 minus 23 greater than 0. So if you could prove that the left-hand side is greater than 0, then job done. So I have taken the left-hand side, which is 41 squared minus 18 lambda, 41 lambda squared minus 18 lambda minus 23. But that can easily be factorized. 41 lambda, and lambda, 23 and minus 1. So the factors are 41 lambda plus 23, lambda minus 21. But we said lambda is greater than 1, so it's positive. So 41 lambda plus 23, they're all positive, so it must be positive. So for lambda greater than 1. Then again, lambda minus 1, because lambda is greater than 1, therefore lambda minus 1 greater than 0 as well. So if those two are greater than 0, the whole thing is greater than 0. Therefore, RT is greater than 0. Then the R is outside the circle. So that's done. Outside the circle, that's part done. The SLK R is outside the circle S. Find the equation of a chord of contacts of the tangent drawn from the point R to the circle S. As lambda greater than 1 already know, vary, show that the chord of contacts passes through a fixed point. Right, okay. This is standard formula we're going to use. Right, the circle is this x minus 1 squared plus y minus squared equal 25, the circle's equation. I just wanted to expand it and separate. So this will be x squared plus y squared minus 2x minus 2y minus 23. If you bring that 25 to left-hand side, you can work it out. I just stepped missed the line. So we have the circle's equation is x squared plus y squared minus, so in the form of that. So if that, it's a standard form, the chord of contacts, I have applied. I just wanted to let you know how that look like. So if the equation x squared plus y squared plus 2gx plus 2fy plus c equals z. If that equation of a circle is like that, the chord of contact will be, so in outside line, say for example outside point, x1, x2. If we say that R is x1, x2, but we're not going to that. So it's a point outside the circle. If it's x1, x2, the coordinates of outside the point, the chord of contacts equation, standard equation, would be x times x1 plus sorry, x y1, x1 y1, yeah, y time y1 plus 2g over 2 x plus x1 plus 2f over 2 y plus y1 plus c equals 0. That's the standard form. That is exactly what I hear, quarter contact equation. The x1 and x2 here is 4 lambda and a 5 lambda. So x times x1, so x times 4 lambda plus y times y1, 5 times 5 1. And then divided by that, the coefficient is 2g divided by, so here's 2, 2 divided by 2 is minus or plus, doesn't matter, minus, and x plus 4 lambda, and again is 2 over 2, y plus 5 lambda minus 23. So if you simplify it, we get a 2 equation. The minus x minus y minus 23, just separated, just expanded and separated, you get to this. And lambda common, 4x plus 5y minus 9. So if you look at it, there are two linear function, linear equation. These are two linear equations. So the above passes through intersection of two lines. So these are the two lines, x plus y plus 23 equals 0, 4x plus 5y minus 9 equals 0. So it's actually the chord of contacts of the equation, chord of contacts passes through these two lines. When two lines meet, it's at a intersection point. That is a fixed point. So these are the two. So it's just a fixed point. So it's line intersect. These two line intersect is a fixed point. Therefore, chord of contacts will go through a fixed point. That is what we have been asked to prove. The last part of the question. Yes, the lambda. So lambda can be, of course, lambda has to be greater than 1 for that r to be outside the circle. That's all. And again, for any value of lambda, the line to r meets, and the intersection will be, fixed. So the chord of contacts pass through the fixed point. Thank you. Please subscribe the channel and share the contents, share this question answer with other students and friends. Thank you.